All right, first one. Anybody notice a pattern in the value of those three terms? What do you got?
Every term is adding 9 onto the equation.
Adding 9 onto the number, you mean? Because really it's an equation here. Yeah. So adding 9. Okay. So what you're telling me here is we went from go to here to there, we're going to add 9. Go from there to there, we're going to add 9. Yes? So if that pattern were to continue, what would the next value be? 55. And then?
64.
And then?
73.
I would concur that on this one, identifying the pattern was we added 9 each time. Yes? Okay. Second one. Anybody see the pattern? You just gave me the last one. So. What do you got? It's half of the previous number, so you multiplied by a half? Yes? Okay. So we multiplied by a half. Anybody know what's the other one? There's another pattern here. One of them is multiplying by a half. Dividing by 2 is the other one. They do the same thing. Yep, multiplying by 1/2. Or divide by 2. So the next one should be then 16, 8, and 4. Yep, I would concur there. Okay. Everybody good with that one? Okay. Use the given equation to find the y values needed to complete each coordinate pair. So this is, remember, points are x comma y. So this would be an x value for me to plug into that equation. And so I'd get y equals -4 times 2 plus 9. -4 times 2 is -8. -8 plus 9 is +1. So that one would be 1. Then I would go to the next one. It would be y equals -4 times -3, then plus 9. -4 times -3 is 12, plus 9 is 21. And I go do it again. -4 times 0 plus 9. That's going to be 0 plus 9. That's just going to be 9. Huh? Questions on that one? Okay. Function notation is, instead of using x and y in equation, like y equals 5x plus 1, or like we just had up here, y equals -4x plus 9, mathematicians often write f of n equals 5n plus 1. Or up here we could have said f of x equals 5x plus 1. Okay, because it can give us more information. With this notation, the direction to find f of 2 means to replace the value of n with 2 and perform the operation. So anywhere that there's an n in that equation, you would plug in 2. Or in this case, it says f of 4. So I'm going to take, I'm going to take 4 and I'm going to replace it anywhere that there's an n in my f equation, and only my f equation. Okay? So this would be then 3 times 4 plus 2. 3 times 4 is 12, plus 2 is 14. So f of 4, and that's how that's read. This isn't f4, okay, or f times 4. This is f of 4. So we took 4, we put it into our function, and the value that we got out was 14. This would be g of 10. So I'm going to take 10, and I'm going to put it into my g function now. So then that's going to be 5 times 10 minus 1. 5 times 10 is 50, minus 1 is 49, so g of 10 is 49. Questions, comments, concerns, clarifications? Talking about patterns again today. All right, so we've got this pattern now at the top of the next page. Okay? So at the beginning we started with 1 dot. Then after 1 minute, our pattern looks like that. Okay? So we added how many dots here? Added 4 dots. Okay? So at the beginning, so that would be like t equals 0. We had 1 dot. At 1 minute, that'd be like t equals 1. We've got how many dots? 5 dots. At t equals 2, so after 2 minutes, now how many dots do we have? How many? 9 dots? 9 dots. Assuming that this pattern is going to continue in the same way, what would the next one look like? Okay, so what would the next one look like first, and then how many dots did we use in it? So what does it look like first? Okay, so we started with our center dot, right? Okay, and then how many shooting off in each of the 4 directions? 3? You get it, Michael, or not? 3, because there'd be 3 total, right? Because there'd be 1 more on top of this, so it'd be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes? Okay, so how many total dots did we use? 13 total dots. How many dots would there be at 4 minutes? How many? 17? Okay. How many, what's our rate of change? What's the change in the dots? Each minute we're adding 4? Adding 4 each minute. Okay? So every minute we're adding 4. Now, do you think that it would make good sense to figure out, so after 3 minutes we're at 13, 4 minutes we're at 17, 5 minutes we're at 21, 6 minutes we're at 25, 7 minutes we're at, and go on and on and on and on and on and on until we get to the 100th minute? No? Okay. So what we're going to do right now is we're going to come up with an equation. Okay? All right? Or a formula, if you will. And we're actually going to do it here in number 4. Okay? Because we're going to combine those two with this table that we're going to come up with here now. So a table, now you can either draw your table vertically or you can draw your table horizontally. I don't care. Okay? The first 2 problems that we had today on the retrieval, those were horizontal tables. Okay? Right? A vertical table is kind of like a T-chart. Okay? Where you've got, in this case it would be minutes, and it would be dots. So we started out with, at 0 minutes, we had 1 dot. At 1 minute, we had 5 dots. At 2 minutes, we had 9 dots. At 3 minutes, we had 13 dots, and so on and so forth, right? Then we said at 4 minutes, we had 17 dots, okay? What this question number 3 is asking is it's asking how many dots are there going to be if we continue with that pattern. Okay? So, we said that our rate of change, or how we are changing, was we were adding 4. Right? That's what you guys told me. Adding 4. What do you got for me? Nope. No, wouldn't be 400. Hold on, we're getting there. Okay? Let's come up with our equation first. Okay? So that means every time we're adding 4, so that means that our equation is going to be 4n. We're going to start there. Because every minute, we're adding 4. And n is a minute now. With me? Okay. Does that work for our first one? If I plug 0 into my function, if I find f of 0, do I get out 1? No. If I plug in f of 1, do I get out 5? No. Okay. So what can I adjust it to make it work? Hold on. What do I need to adjust this to? Yeah. What do I have to adjust it to? No. Plus 1. If I added a plus 1 here, right, now it works out. If I plug in 0, 4 times 0 is 0, plus 1 is 1. 1 times 4 is 4, plus 1 is 5. Okay? It's that middle dot that we started with. So if you think about this equation, this number here is your rate of change, right? And this number here is your starting value. Now, it's very easy to plug in how many we need at 100 minutes. Because now I can just find f of 100. I can plug in 100 into my equation here. 4 times 100 is 400, plus 1 is 401 dots. What we found there is something called the explicit equation. The explicit equation is the equation used to find any term in your sequence. Okay? Some people also might refer to the explicit equation as the rule. Okay? It's the rule of your sequence. It's how you find each and every one. In this particular case, it was 4n plus 1. the recursive equation is used to find the next term. So the recursive equation, you can only get the next term out of it. Okay? So in this particular case, it would be f of n plus 1, that's my next term, is equal to my current term plus 4. My next term is equal to my current term, and however my rate of change is. In this case, my rate of change was adding 4, so it's plus 4 there. Questions on that? You individually now come up with a pattern of dots that increases by 3 each minute, and you start with 1 dot. Okay? So everybody's first thing, so starting point or your starting pattern is everybody's is going to be that. Okay? Because everybody starts with 1 dot. Your pattern now is going to go up by 3 dots every time. Okay? Right? Then I want you to make an explicit equation for yours. Your patterns can be all different, but your explicit equation is all going to be the same because everybody's starting with 1 dot and everybody's going up by 3 dots. Okay, now you get to choose your color. Down there, yep. Okay. Fairly certain that we're in math class, we're not in Spanish or German. Give me one more. Anybody have a different pattern? Or did everybody do like the 3-pronged approach like this? Anybody else have a different pattern? Okay. What was our explicit equation for everyone's pattern? Everybody should have been 3n plus 1. Okay? Because we all started at 1, and our rate of change was plus 3 every time. Okay? All right? Love it. So, a couple of things to take away from today. So, a table it can be vertical or horizontal. But it's got 2 rows or columns in it, okay, depending on verticality or horizontalness. Okay? Alright? We didn't talk about the graph today, but that's fine. Okay? An explicit equation finds any term, and a recursive equation finds the next term only. Okay. So an explicit equation finds any term that we want. Recursive equation finds the next term only. And then again, just a little note here about function notation. Okay. F of n is the term value. And that's how we say that. Okay. F of n. Okay. And then we plug in that number for the term number. Okay? Questions on that? Your homework this evening is now in the yellow packet, pages 5 through 7. It is ready, set, go on problems number 1 through 23.